Hey math kids, we're going to continue talking about 2C. This time we're going to focus on exponential growth and recursive equations. So there's a guy playing a video game, and to get to the next stage, he has to triple his points from where he was at before. So experience points. And so on stage 1, he needed 1 experience point. For stage 2, he needed 3. Stage 3, he needed 9. Stage 4, 27. Okay. Because we're multiplying to get from step to step to step, it's an exponential relationship. And since we're going to say y equals ab to the x. So we are starting at we're starting at 1. So we're going to plug in a. And then we're growing by 3 each time. Then we raise it to the x, and we do that. So this simplifies down to y equals 3 to the x. Now, this is just like a educated guess at this point. Once again, the reason why I chose 3 is because all of these are multiplied by 3. And if I plug in a 1, I want to see what I get. So y equals 3 to the 1. That equals 3. So that's claiming if I plug in a 1, I get a 3. So our thing is off by 1. Because watch, when I do y equals 3 squared, I get 9. Plugged in a 2, but I ended up with a 9. So we're off by 1. So what we actually want to do, we want to modify this to have a negative 1 right here. So now if we try that first one again, it's y equals 3 to the 1 minus 1, which is 3 to the 0, which is 1. And so 1 goes to 1, and that's what we want. Test it for the next one. 3 squared minus 1 equals 3 to the 1, which is 3. So when you plug in a 2, you end up with a 3. And we'll try one more, just to feel good about it. 3 to the 3 minus 1 is 3 squared, which is 9. When we plugged in a 3, we got a 9. And I feel confident that the next one would work as well. So that's how you do those ones. Now, if let's say we had a population of elves, and let's see, over 4 years, we got more and more elves at our elf zoo. We're going to let a sub 0 equal 1, and we want to see a recurrence relationship that matches this data. Okay, so what we're going to do is we're going to, it's going to be this notation, a of n. Now we need to see what type of growth we have. So we're multiplying by 2, multiplying by 2, multiplying by 2. So we start at 1, or a naught, and since we're multiplying, we just need to multiply this by whatever. So a sub n equals 2 times n plus 1. So let's try, that's explicit form. That would just be the y equals 2n plus 1. Now, if we start at 1, it's just going to be 2 times a of n minus 1. So I'm going to throw that out, and let's see if that works. Sorry, this was explicit. That's what we did on the previous video. This is recursive. So recursive means just what do you need to do to the previous term to get the next term. And so if we focus on 1, we plug in a 1, or let's see, let's just say, so this is a sub 0, this is a sub 1, a sub 2, a sub 3. So if I want to know a sub 1, I'm going to say a sub 1 equals 2 times n minus 1, so that's just the previous term, so a sub 0. So 2 times 1 equals 2, and so a sub 1 must equal 2, and that's what we see right there. Now let's try a sub 3, for example. So if I want to know a sub 3, I'm going to do 2 times the previous term, which is a sub 2, which is 4. Multiply those together, I get 8, and so a sub 3 must be 8. Okay, hopefully that made sense. Let's try another one. Okay, so for this one, we notice that we're adding 3 each time. So we're gonna, a sub 0 is 1, a sub n equals 3 plus a sub n minus 1. And so if we want to know what, so this is a0, a1, a2, a3. So a1 would be 3 plus a0, because it's 1 less than whatever this is. 0 is 1 less than 1. So a sub 0 is 1, so 3 plus 1 is 4. And so our a1 is in fact 4. Let's just test this last one. So let's say a3 equals 3 plus the previous term, which was 7. And so a3 equals 10. And we see that works. Now if we wanted to get a4, all we'd have to do is add 3 to that, and so it's 13. Okay, hopefully that's pretty straightforward. Okay, now we're going to go back to a problem that we did on the previous video, and we did it in explicit form. But now we're going to do it in recursive form. So we want to write in a recursive equation for this situation. So we have 1, then we have 5, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the relationship is we're adding 4 each time. And so for recursive, we just say a of n equals 4 plus a of n minus 1. And that's all we have to do. It takes a lot less thinking. Okay, we had another problem. I think it was this. So we had 1, 2, 4. That situation is multiplying by 2 each time. And so we just say a of n equals 2 times a of n minus 1. Because each time we have to multiply the previous term by 2. Okay? And then the last thing I want to talk about on this video is starting to talk a little bit about rational functions. So don't get scared by that name, but I'll just show you what we do. And this is leading us into factoring as well. So we'll have to use some factoring. So let's do, x squared plus 5x g of x equals x squared minus 25. And it wants us to find g of x. Now I'll switch this up. Let's find f of x over g of x. Okay, so the first step is we just want to replace each of these with each of these. So f of x is on top, so I just say x squared plus 5x. G of x is on the bottom, x squared minus 25. Now, it might look like we can't simplify this, but I'm going to ask you to factor. So on the top, we have an x squared and an x, so that means we can take an x out. And if we were to divide this by x, we'd be left with an x. And if we divided this by an x, we'll be left with a 5. Now, just to double check that you got that step right, you can distribute x times x is x squared, x times 5 is 5x, so we did that correctly. Now, this is actually something called difference of squares method, which we haven't covered yet. The answer, I will write it, but then I'll show you how you can figure it out with the knowledge that you know. So the knowledge that you know, you can actually t-factor. So if we thought of the bottom as x squared plus 0x minus 25, we can figure this out. So we t-factor 1 and 25, 5 and 5. We want them to add up to this term, which is 0. So we'll have to do a negative 5. Negative 5 times 5 is 25, so that works. And so we just say x minus 5, x plus 5, which is the same thing we got right there. Okay, once we have all that stuff factored, here I'll even fill this out. Once we have this factored, we have an x plus 5 and an x plus 5, so let's cancel. And so what's left is x over x minus 5. And that's all you have to do on that one. Now let's try one more of those, just for good measure. So h of x, p of x, x squared plus 3x, x cubed minus 6x. And this time we want to find h of x over p of x. So we just plug them in. So x squared plus 3x goes on top, x cubed minus 6x on bottom. Both of these can only be factored using the reverse distribution thing. So x plus 3. So they both have an x in common, so I took out one x, put it right there. And then these only have an x in common, so I'm left with x squared minus 6. This time these x's cancel, and then we're left with x plus 3 over x squared minus 6. And that's all we can do. You can try to factor this. I don't think it's going to work though, because we would do x squared plus 0x minus 6, 1 and 6, 2 and 3. There's no way to subtract or add to make 0, and so this really is our final answer. If you need additional help, please come to Math Lab. Until then, calculator.